Hey there, and welcome. Have you ever looked at a circuit and just thought, how in the world do we measure something as invisible and powerful as electricity? Well, if you're studying for an exam or you're just curious, you are in exactly the right place. In this explainer, we are going to pull back the curtain on these essential tools, starting from the very heart of how they work. So here's our game plan. First, we'll uncover the clever little trick that lets us actually see electricity. Then, we'll meet the big three tools for the job: the ammeter for flow, the voltmeter for pressure, and the ohmmeter for resistance. After that, we'll see how they all come together in one handy device, the multimeter. And then we'll wrap it all up with a quick review to make sure it all sticks. Sound good? Let's jump in. All right, let's kick things off with the most basic question of all. Electricity is totally invisible, so how on earth do we actually measure it? What's the secret sauce? Right? You can't just stare at a wire and count the electrons flowing by. The answer is pretty ingenious. We have to turn that invisible electrical energy into something we can see, a physical mechanical movement. And that's where this amazing little device comes into the picture. Meet the D'Arsenval movement. This little guy is basically the tiny engine that powers most of the analog meters we're going to talk about today. You can think of it as the fundamental building block that really unlocked our ability to measure electricity. If you understand this one mechanism, everything else is going to click into place. The idea behind it is actually beautiful in its simplicity. We take the current we want to measure and run it through a tiny coil of wire. What does that do? It turns the coil into a temporary magnet, an electromagnet. This new magnet then tries to push away from a permanent magnet that's fixed inside the meter. And here's the magic. The more current you have, the stronger that push is, and the further the needle moves across the scale. It gives us a direct visual readout of the current strength. Okay, so now that we get the basic idea of turning current into movement, let's build our first real tool. We can take that D'Arsenval movement and use it to measure the flow of electricity, and that tool is called an ammeter. So an ammeter's whole job is to measure the volume of electrical flow. I want you to think of it just like a flow meter you'd put in a water pipe to measure gallons per minute. Except here, instead of gallons, we're measuring the amount of electrical charge, and we call that unit amperes, or just amps for short. It's literally an ampere meter. Now, this next point is absolutely critical, probably the most important thing to remember about ammeters. If you want to measure the flow of water in a pipe, you have to put the meter inside the pipe, right? It's the exact same principle here. You have to physically break the circuit open and insert the ammeter so that all the current has to flow through it. We call this connecting in series. This diagram from the NEATS manual shows it perfectly. Just trace the path of the current with your eyes. It flows from the battery, goes through the ammeter, and then continues on to the light bulb. The meter is literally in line, part of the chain of components. And why is this so important to get right? Well, an ammeter is designed to have almost zero resistance. It's supposed to be like a seamless piece of wire. If you connect it the wrong way, which is called in parallel, you're basically creating a massive shortcut for the electricity to bypass everything else. That causes a huge surge of current that will instantly fry the meter's delicate insides. Okay, so we've got a handle on measuring flow, but what about the push, or the electrical pressure that's making it flow in the first place? Well, we can use the exact same D'Arsenval movement to measure that too, using a tool called a voltmeter. So while the ammeter measures the volume of electricity flowing, the voltmeter is all about measuring the electrical pressure that's pushing those electrons along. It measures the difference in electrical potential between two different points in a circuit. And here's where things are the complete opposite of the ammeter. To measure a pressure difference, you don't break the circuit at all. You just take your two probes and touch them on either side of the component you want to measure. This is called connecting in parallel. You're measuring the drop in pressure across that component. Okay, pay close attention to this slide. This is the ultimate cheat sheet for your exam. Ammeters measure current, connect in series, and have very low resistance. Voltmeters, on the other hand, measure voltage, connect in parallel, and have very high resistance. And that high resistance is super important. It makes sure the voltmeter doesn't steal any current from the circuit while it's trying to take a reading. So we've covered flow and pressure. The last big piece of our puzzle is resistance, which is just the opposition to that flow. To measure this, we use an ohm meter. And this tool is a little different. It has a unique trick up its sleeve. It brings its own power to the party. The job of an ohm meter is to see just how much a component is fighting against the flow of electricity. But the key thing to remember, the absolute game changer, is that it has its own battery inside. It works by sending out its own small, very precise test current through a component, and then it measures what happens to figure out the resistance. Now, because the ohmmeter has its own battery, this leads us to the single most important safety rule in all of meter usage. You can never, ever use an ohmmeter on a circuit that is powered on. You have to de-energize it first. If you don't, you'll be jamming the circuit's voltage right back into the meter's little battery, and poof, you'll destroy it instantly. Always, always power down first. So let's see, we've got 3 different meters for 3 different jobs. That sounds kind of like a lot to carry around in a toolbox, right? Well, luckily, engineers thought so too, and they combined all 3 functions into one incredibly versatile device. And here it is, the multimeter. Just like the name says, it's a multifunction meter. With a simple turn of that big dial in the middle, you can tell it, okay, now you're a voltmeter, or hey, be an ammeter, or time to be an ohmmeter. It really is the Swiss Army knife for anyone who works with electronics.
Whew. Okay, we've covered a lot of ground, from that tiny Darson ball movement all the way to the do-it-all multimeter. Now let's lock in all that knowledge with a super quick review and a couple of practice questions to see what you've learned.
You're ready? Let's do a quick hitter review of the most important ideas. Okay, remember, the Darson ball movement is the engine. An ammeter measures flow, so it goes in series. A voltmeter measures pressure, so it goes in parallel. An ohmmeter has its own power, so the circuit must be off. And the multimeter, it's the one tool that does it all. Got it?
All right, first question for you. How does an ammeter connect to a circuit, and what's its ideal internal resistance? Think about it for a second. To measure flow, it has to be part of the flow, right? So it connects in series. And you don't want it to block that flow, so its resistance needs to be as close to 0 as possible.
And for our last question, why do you have to de-energize a circuit before you use an ohmmeter? Remember the key feature? The ohmmeter has its own battery. If you connect it to a live circuit, you're sending external power to fight against its battery, and that will absolutely damage the meter. It is the #1 rule of measuring resistance. Hey, thanks for joining me for this explainer. Keep practicing these concepts, and you are going to master these tools in no time.